Hello everyone. Firstly, let me introduce my name. My name is Abel Henrik Maroko Panjaitan. I'm from TI 23 class and majoring in informatics engineering. So, for this moment, I will explain about the five subject of matter or material in the algorithm and data structure. So, firstly, what is the binary search? Binary search is important in solving problem because it offers an efficient way to search for element in a short list or array. It works by repeatedly dividing the search space in half, eliminating the need to search through every element. This results in a significant reduction in the number of comparisons required, making it a fast and effective search algorithm. For example, let's say that we have sort array 1, 3, 5, 7, 9, and 11, and we want to find the index of the element 7. With a binary search, we start by comparing the middle element, which is 5 in this list, in this array, I mean. Since the 7 is greater than 5, we know that it must be in the second half array. We then repeat the process on the second half, which is in 7, 9, 11, and find that 7 is the first element in that subarray. By using binary search, we were able to find that element 7 is only take a few comparisons even in a larger array. This makes it a valuable tool for solving problems that involve searching or finding specific element in short data structure. So, for example, here I made the three code here, but I will run just one code or one algorithm for show you how the binary search perform. Okay, let's run it. So here we want to find the element 8 in this array. The array is consists of 3, 4, 5, 6, 7, 8, and 9. Then with this algorithm, we can separate the array by the two half, the left half and the right half. Then we compare it to find the element that we want. So let's run it. Okay. For the element 8, we can find the element at index 5, which is here. Is index 0, is index 1, is index 2, is index 3, is index 4, and is index 5, exactly at index 5. And number of steps for find this is 1. So it's all about the binary search. Let's we move to the bubble sort. So bubble sort is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements and swap them if they are in the wrong order. Bubble sort is like organizing a deck of cards by comparing adjacent cards and swapping them if they are in the wrong order. For example, if you have a number of 5, 3, 8, 2, and 1, bubble sort will start by comparing 5 and 3, then 5 and 8, then 8 and 2, and finally 8 and 1. It will swap the numbers as needed to eventually sort them in ascending order. It's not very efficient for large datasets and is mainly using for educational purpose or small datasets where simplicity is more important than speed. Bubble sort can be used to solve simple sorting problems where efficiency is not major concern. It's not ideal for a large dataset due to its low performance compared to more efficient sorting algorithms like quicksort or merge sort or merge sort. So for the example here, I have a code. This code will show us about the number of iteration and the result of the algorithm. Then we run this. I'm sorry. Okay, so we got here. This is the final result, and this is the step of history about the iteration. So also to show us how many looping or step that we that required to sort this. So it's all about the bubble sort. Let's move to the quick sort. Quick sort is a divide and conquer sorting algorithm that works by selecting a pivot element from the array and partitioning the other element into two subarray according to whether they are less than or greater than the, the pivot. The subarray are then sorted recursively. The efficiency of quick sort can be analyzed mathematically to show that on average it takes O and log m comparison to sort n items. However, in the worst case, it makes O n square comparisons. The worst case generally occurs when the pivot element is the smallest or largest element in the array, resulting in one subarray having only one element and the other subarray having all the other elements. This can cause a highly unbalanced tree structure, leading to inefficient sorting. To mitigate this issue, first pivot selection schemes have been proposed, such as the median of tree rule, which choose the pivot as the median of the first, middle, and the last element of the array. This rule improves the expected number of comparisons to C and 1 equal to 1.188 n log n at the expense of the 3% increase in the expected number of swaps. Quicksort is a popular sorting algorithm due to its efficiency and simplicity. It's widely used in practice and has been implemented in many programming languages such as C, Java. However, it's not a stable sort, meaning that it might not preserve the relative order of equal elements. Therefore, other sorting algorithms such as merge sort may have a preferred in situations where stability is required. So for the quicksort, we have the example here. We take also here we have an example of the quicksort algorithm. So we want to sort this array that consists of 3, 6, 8, 10, and 1, 2, and 1 again. Then we run it. So this is for the code. We got the result is that show that the iteration, the the array that before the sorting of every each iteration, and the code and the array that after sorting, and the final form of the sorting. So it's all about the quick sort. Then we can move to the tree. Okay, let's we talk about the tree. Tree is actually the linked list. In a tree data structure, elements are organized in a hier- hierarchical manner, with a single root node and branches leading to various child nodes. Each node can have multiple children but only one parent, creating a parent-child relationship. The structure is valuable for scenarios where data exhibit a hierarchical nature. One prominent example is the file system of computer. The root directory serves as a starting point, branching into subdirectories and files. Each subdirectories can further branch into more subdirectories or contains files. This hierarchical arrangement allows for efficient organization and retrieval of files, making it easier for user and application to navigate and manage data. 3. Also fundamental in database network routing algorithms and hierarchical relationship and organizational structure. Among many other applications, their versatility and efficient characteristics make them a foundational concept in the computer science and information management. So after we talk about the tree, we have to talk about tree traversal. Tree traversal. The tree traversal is aren't linear, so there is no clear way to traverse through everything. There is two different broad approach to tree traversal, which is DFS, depth first search, which is if they're children, not to explore. Exploring them is priority, but there is several different approach. The first is pre-order traversal, is check off the node as you see it before you traverse any further in the tree. And practice is first you have to start at the root, then immediately check off that we've seen it. The second, we pick one of the children from left and check off of it. Then we traversing to the most left node until we have a leaf. Next, check off the leaf and go back to the parent. Then traverse into the right child and check it off too. After we're done with the first subtree, then back to the root. And then move to another child on the right with the same step until entire tree is checked. The second type is in order traversal. Is check off the node only when we have seen its left child and come back to it. The order is explained like this. Start on the root, traversing down to the leaf, check off the leaf, then move to the parent. After seeing all the left child, check off the parent, then move to the right node. If the node has no children left, then we check off the node. Back to the root, move to the right nodes with the same process. And the third or less of this DFS is post-order traversal. Is we have to see all of the descendants or we visited both of its children and return. Begin at the root, but don't check it off. Continue to the leaf. Check off the leaf, then move to the parent, but don't check it off. Move to the right nodes. Once we check off the right child, we can go back to the parent and check it off. We skip over the root node and move all the way down to the right and check off it all with the same process. Then go back to the root and check it out. And the second approach of the traversal is BFS, breadth first search, which is its priority is visiting every node in the same level where currently on before visiting child node. Example of BFS is level order traversal. Firstly, we visit the root, then visit the children on the second level, then all of the children of the third level, and so on. Until we visit all single leaf, we start from the left to the right. So that's all about the tree traversal that consists of depth first search and breadth first search. So to show you about the tree and tree traversal, I've made the code that not visuals but will explain it to you how it works and perform. So tree is actually linked list as mentioned before. So here is the beginning of the list that is not one or root. Then we move to the left side is consists of node 2 and node 2 has as children that node 4 and node 5. Then in the right side we have 3. So in this code we can perform that will show us the 3 result in DFS approach, which is in order traversal, pre-order traversal, and post-order traversal. So here is the result. You can see that the order of each traversal is different because the method or the way to traverse every node is different. So it's all about the tree and tree traversal. Let's move to the graph. Graph in computer science is data structure that consists of the set of nodes called the vertices and set of edges that connect these vertices. Vertices represent entities and edges represent a relationship or connection between these entities. So for the example of vertex is this, the node is 1, vertex 2, vertex 3, and vertex 4. And this line that connects every vertex is called edges. Vertex, these are fundamental building block of graph, represent, representing entities for object. For example, in social network, vertex could represent the user, like this user 1, user 2, user 3, user 4. While in the transportation system, they might represent a location. And the edge, these are fundamental building blocks. And then the edge are connection or relationship between the vertex. They define how the vertex are related. In social networks, as edges could represent the friendship. This vertex user 1 is friendship with user 2 in example. And in transportation system, they might represent the road or routes between the location. Graph can be classified into the various types of on their characteristic. First one is directed graph. The edges have a direction indicating one-way relationship between the vertices. Like this, maybe the edges is just move one one direction, like 1 to 2 to 4 and 2 3, then back to the 1 if looping. Then undirected graph. The edges have no direction, indicating the two-way relationship like this, the 3 and the 2 vertices that connect with these edges. And 4 is cyclic graph, contains at least one cycle, a sequence of vertex where the last vertex is connected to the first, like this, from 1 to 2 to 4 to 3, and then back to the 1. This is a cyclic graph. Then a cyclic graph doesn't contain any cycle. For example, this one, then move to 2, then move to 4, then move to 3, then not cycling to the, or not go, not connect to the 1. It will stop here. So in real life, example is social network. Consider a social network where each person is vertex and a friendship are represented by edges. This graph help model and analyze relationship between the individuals. Algorithms on graph can be used to find the sorted path between two users, identify influential user or even recommend the new connection. In daily life, social media platforms like Facebook or LinkedIn use graph algorithm to suggest friends or connection based on a mutual connection or shared interest. This demonstrates how graph structure and algorithms are crucial for solving the real-world problems and enhancing user experience. So I think that's all that I can explain to you. I'm sorry for the lack of everything or I'm sorry for the mistake that I made during this presentation, especially about my pronunciation that not really good. But I hope this video is will clear to you to inform the what is the bubble short, what is the binary search, what is the quick sort, the tree, and also the graph. And that is all. Thank you for watching. See you next time.